Okay? So for this particular problem, we talked about yesterday what all these things stand for. So you're supposed to know that already. It's in your notes. This particular problem says a rock is thrown from ground level. Well, that means its initial height, this is the initial height. If it's at ground level, the initial height is 0. So for this problem, that's a 0. With an initial velocity of 32.
We didn't finish the one from yesterday.
This is the one from yesterday. This is problem number 4 on the note sheet. I'm looking at A.
We got the A.
Oh, I'm sorry. Oh, I'm sorry. I was looking at the wrong one. I forgot. Okay, it's all right. It's okay. Let's back up and finish 3. Okay. This is still the initial height, but it changes. If we're doing problem 3, it is thrown off the top of a building 12 feet tall. So this would be 12. With an initial velocity of 18 feet per second, so this is 18. And this, of course, just stays the same. So my height for this problem, this is going to be the equation I'm going to use. My height is negative 16t squared plus 18t plus 12. Now, when will it hit the ground? I need you to look at your equation, kids. There are 2 variables in your equation. This side talks about height. This side talks about time. T is time.
Wait, what's the S stand for?
When it says, when will it hit the ground, what do we know? We have to know one or the other because we got to plug something into that equation. If it's on the ground, its height is 0. So we're going to put 0 here and solve this equation.
Will it sometimes be different than 0? Or will it always be 0?
Katie, if it's
Yes,
on
0.
the ground,
Oh, it's going to be 0.
how high will it be? Yes. Now, it's not always going to be on the ground.
Yeah, that's
but
what
if
I
it's
thought.
on the ground, its height is 0. Now, how do I solve that? What kind of equation is that? That's a quadratic equation. And how do I solve quadratic equations?
Gotcha.
I could factor. Ooh, those got some big numbers in there. Maybe I don't want to factor. I could use the quadratic formula. I could use the quadratic formula. So A would be negative 16, B would be 18, and C would be 12.
Yeah.
Now those are still big numbers, but I have a calculator that will help me. So T will equal, instead of X's this time we have T's,
The greatest common factor?
negative B plus or minus the square root of B squared minus 4 times A times C all over 2A. Now, Katie says, well, Mrs. Ford, it looks like I could take a 2 out of here. And if you wanted to do that, you absolutely could. It wouldn't hurt a thing to divide everything by 2. It's not going to help me shrink it that much, but it will make it a little bit smaller. I already wrote it down, so I'm not going to do that, but you absolutely could. That would be okay. So what's 18 squared?
That's 296.
No, it's 324.
That's my boy.
Calculate, I just said
That's my boy, you friend.
Now, be careful here. You have a negative times a negative, right? So that's going to end up, that becomes a plus.
You know how to do what 5 No,
Now, how many answers do I have here, kids?
2.
I have 2. Right? So I'm going to solve each one individually. So one of my answers will be negative 18 plus the square root of 1092 over negative 32. And the other one will be negative 18 minus the square root of 1092 over negative 32. So I'm just going to type that into my calculator. So negative 18 plus the square root of 1092 equals, after you put in your numerator, please hit equals, divided by negative 32. Oh, shoot. I got a negative number. Why does that bother me a little bit?
Can't have a
Because
negative.
you can't go below.
What am I solving for?
Time.
Time.
It's extraneous.
That seems like an extraneous root. We'll look at it in a minute. Let me do the second one. Negative 18 minus the square root of 1092 equals, divided by negative 32. For that one, I got 1.6, about 1.6 seconds.
Dang, that's bad.
Now, I want to draw a picture of this scenario to help you understand why we got the bad answer. We got one good answer, and we got one bad answer. Let's draw a picture of this. Here's my coordinate axis system. Here's my building that's 12 feet tall. Here I am on top of the building. I'm going to throw my ball up, and here it comes crashing down to the earth. Now, did I get the whole parabola this time? No, because there's a piece of it that would be back here, right, if I finished it up? But that doesn't really count because we started at the top of the building. But guess what this answer is? That is your negative 0.47. So it doesn't really count in this problem, so you're right, it's extraneous. But that's why it came up, because it's actually a piece of the parabola. This is when it hits the ground, and that's at 1.6
So negative
seconds.
0.47 is how long it would have taken for it to go from the ground to 12 feet?
Yes, exactly. Had it been thrown from ground level. Yeah. Okay, so the only answer to the problem is 1.6. Everybody okay with that? All right, let's look at the second one. When will it be 15 feet above the ground? Now, we are still using the same equation. So we're still using this. They gave me a 15. When will it be 15 feet above the ground? Am I going to put the 15 in for the H, or am I going to put the 15 in for the T?
H.
H. Why H?
The height.
Because it's the height. Exactly. When's it going to be 15 feet above the ground? So remember, the ball started on the 12-foot building, right? So here maybe is 15. This might be 15. We want to know, when is the ball 15 feet above the ground? So we'll just put 15 here. So 15 equals. Now what are you going to do with that equation?
The same thing, but then you.
Well, we got to do something before we do the same thing.
subtract.
We're going to do the same thing, but first we're going to move the 15. So yes, indeed, we are going to do exactly the same thing. This is another quadratic equation.
I feel like this.
If you want to try to factor it, go ahead. I'm not going to. I remember from my last problem that b squared is 324. This time I am going to have a minus. So what are my two answers going to be? Is everybody keeping up with me, okay?
Mm-hmm.
Bryce, the pages, the seat next to the page is open. If you want to come up and sit there, that would be great. So what do I get? Erase that equation and squeeze it in somewhere. Where can I squeeze it in? So t will equal negative 18 plus root 132 over negative 32, or negative 18 minus root 132 over negative 32. Remember, when you type this in, please, 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 negative 18 plus the square root of 132 equals, make sure you hit equals, and then divided by negative 32. I got 0.2. I'd love it if somebody would tell me you got that too.
Wait, how do you get it on a calculator? What do you press?
And this one is 0.9. Okay, so I press negative 18 plus the square root of 132 equals, it equals, and then divided by negative 32. Now, I got 0.2 and 0.9. Can you see why there are two answers, you guys?
Cross the bracket.
You hit 15 feet once on the way up, and then once on the way down. So it took it 2 seconds to get up here, and then it took it 0.9 seconds to get, 0.2 seconds to get here, and then 0.9 seconds to get over here. Last question. How high is it after 1 second? So go back to your equation. How high is it after 1 second? Right, remember, they gave you the number 1. So you're going to do something with the 1. You've got to put it in for the H, you've got to put it in for the T. T, it's 1 second. So all you're going to do is put 1 in there for the T. So what are you going to end up with? We put in 1, we get negative 16 plus 18 plus 12, 14. Just put 1 in for the T's. That was easy, wasn't it?
I have to get rid of this square.
What's 1 squared?
Oh, yeah.
Now, number 4, this is the one I was starting before when I shouldn't have been. We got to start over again with a new equation. This is a new problem. We're going to have a new equation. We're going to use this as our format. This is what I will give you, but we got to make it unique to this problem. So now I'm on number 4. Okay? A rock is thrown from ground level. We talked about that. What does that mean?
0.
What's 0?
The S.
The initial height. This right here, the initial height is 0. It is 0 in there. With a velocity of 32 feet per second. So this is 32. Would you agree with that? So the equation we're going to use in these problems, for this set of problems, is negative 16t squared plus 32t plus 0,
Yeah.
which I'm not even going to put the plus 0 because that's just going to confuse me. Maya McLaurin, you all right back there? She sounded asleep.
No. She's right away.
Maya, you all right? You need to go to the office? Okay. All right, letter A. When will it hit the ground? Now, stop. There are 2 variables in this problem. Every single time you're going to plug something in. That's how you solve it. You gotta plug something in. So when is it on the ground? What do I know if it's on the ground? Its height is 0. So I'm gonna go ahead and put 0 in for the height. Now, is that a quadratic equation? Yes. Actually, while you could use the quadratic formula, this one's going to factor really easily. So I'm going to go ahead and factor it because I can take out a negative 16t from both of these terms. See, there's no number here to complicate it. So I can just take out a negative 16t. What will that leave me with if I take out a negative 16t here?
T minus 2.
A t minus 2. That's exactly what it'll leave me with. And if I choose to do the problem this way, which I am choosing because it's the easiest way this time, then what do I do with my two factors once I get them spread up like this? Set them equal to 0. So I get two answers, don't I? What answer do I get out of this? 0 and 2. So 0 seconds and 2 seconds. Now wait a second. Does that make sense? Think about what happened in the problem. In this problem,
It's on the ground.
it started on the ground, we threw it up, and it came back down to the ground, right? Does it make sense that one of your answers was 0?
Yeah.
That's where it started. And then this one is 2. How high will it be after 1/2 second? Here's your equation. This is the equation you're using, kids, for every one of these problems. How high will it be after 1/2 second? What are you going to do with the 1/2?
Plug it in.
Plug it in. Where?
T.
T. So H will equal negative 16 times 1/2 squared plus 32 times 1/2.
Yes.
Maya Brownlow, what's 1/2 squared? No. Remember when we square a fraction, we times it by itself, which means we take top times top and bottom times bottom. So what will that be? 1/4. Now, what's 1/4 of 16?
4.
So this would be negative 4. What's 1/2 of 32? 16. So the answer to the question is 12 feet. When will it be 20 feet high? Here's our equation. They gave me the number 20.
So 20 over 8.
Do I put the 20 in for H or the 20 in for T?
H.
H. So now I'm going to have the equation 20 equals that. Now be careful. How are you going to start this problem? And subtract 20, very good. Now, this was Katie's point earlier. She said, Mrs. Ford, if it shrinks, can I shrink it? And the answer is absolutely. So last time I didn't do it because I'd already started by the time she said that. But since we're here, is this shrinkable? What could I get out of it?
4.
A 4. So I'm going to go ahead and take a 4 out. So basically I'm dividing everything by 4. Perfectly legit. So if I do that, I have negative 4t squared plus 8t minus 5. Now, do you have to do that?
No.
No, absolutely not. But this is going to make my numbers a little bit smaller. So you do it if you want, you don't have to. Okay, so what's t gonna equal? Negative b plus or minus the square root of b squared, b squared, minus 4 times a times c, all over 2a.
Wait, wouldn't it be negative 80?
Oh, it would be negative 80. Thank you, it is negative 80. This is bad news.
No solution.
What does this mean?
I.
Okay, now wait, let's go back to the problem.
Imaginary.
When will it be 20 feet high? At an imaginary time, right? Which means what?
No solution.
It never gets that high. When we threw this ball up into the air, up here is 20 feet, and guess what? It never got that high.
Why did it I?
Because we got an imaginary time. Time can't be imaginary, but that's what happened. Okay? All right. We're done with that note sheet. Notice that the next section starts on that, so please don't lose this paper. Hang on to it, but we're done with it for a few days. Now we're going to start wrapping things up and reviewing. So, you have put your 3 practice tests into your notebook. So what I would like for you to do,
Tired.
Then why do you want it to? I don't, because then I have an add-on.
is get them out or open up your notebook and look at these 3 practice tests. One of them is called practice test 2, one of them is called practice test 3, and one of them is just called practice test.
Oh, here.
And then you got the book review too, that's stuff extra I gave you, I'm not looking at that, I'm looking at the 3 practice tests. Now, would you take a look at practice test 2 and 3? Would you just take a quick gander at 2 and 3? What do you notice about them?
They're pretty much
They are exactly the same thing. Would you agree with that? Now, so is the other one, except things are a little out of order on the other one. Practice tests 2 and 3 are exactly in the same order, same format, same everything as your test. The only thing that's different is, for the practice tests, I have the answers stapled to the back. For the real test, they won't be. My suggestion to you is tonight's homework is going to be the first one, not 2 and 3. We're saving those for tomorrow and the next day. But we're going to do the first one, the one that doesn't have a number on it. My suggestion to you is, if you think you might want to practice any of these more than one time, that maybe you take a picture of it before you start writing on it, or that you make a copy of it, a photocopy in the library, so that if you want to do it again, you will be able to do it again. I'm not providing you with more copies. You have 3 practice tests. If you want to practice them some more, take a picture, make a copy yourself. Okay? So we're going to look at the first one. The one that's tonight's homework is called Precal C Practice Test E. There's no number. It has all the same problems on it, but they're out of order a little bit. Turn to the back page. Not the answers, but the back page of the actual practice test. Look at question number 9.
Oh, I gave it, that's fine.
What is question number 9? Projectile motion. This is on your test. We have to be able to do it. So let's work through this one together. Notice I gave you the formula because I promised I would. It'll be on your test. You just need to write the equation for this problem. Okay, so here we go. What's going to go in blank A? What is the equation for this problem?
Negative 16t squared.
Negative S, we'll use H. H equals negative 16t squared
Plus 20t
plus 20t
plus 30.
plus 30. Now let's stop there and make sure everybody's with us. Everybody understand why the 20's and where it is and the 30's where it is? Okay. When does the ball hit the ground? You're going to use this equation to answer that question. So you're going to have to plug something in. You always plug something in. When does the ball hit the ground? What will I plug in? 0 for what? H. Because if the ball is on the ground